We can record pressure variations in sound waves with this kind of instrument, an oscillograph. Sound waves are striking the diaphragm at the left. The stylus records the sound waves as a graph. Later, we shall use such graphs to represent sound waves. Condensations cause the stylus to move upward. Rarefactions cause it to move downward. So far, we've seen how sound waves are produced. Next, we'll identify three auditory effects of musical sounds: loudness, pitch, and quality. We begin with loudness. Every sound sets up a disturbance in the transmitting medium. The larger the disturbance or displacement of the individual particles, the greater is the height of its graph above the neutral line. This displacement above the neutral line is called amplitude, and it is amplitude that determines loudness. As its loudness increases. Next, let us consider pitch, the auditory effect of frequency. First, we hear the sound of middle C. Next, we hear G below middle C. And now the sound of C below middle C. What causes such differences in pitch? To explain such differences, we picture two different sound waves. Here, the lower fork makes more complete vibrations per second. Therefore, its frequency is greater. It is evident that the one with the greater frequency has the higher pitch.